So now we're going to talk about the third most prominent OWASP of the top 10 security vulnerabilities. This one's called cross-site scripting. With cross-site scripting, it enables the attacker to execute scripts in the victim's browser. Who can do this? Anyone who has access to put input into your system, and internal users, external users, administrators, and with that you'll see there's a lot of similarities between this and the first vulnerability that we talked about, the injection vulnerabilities. A lot of similarities. The attack vectors, average difficulty to actually launch this type of attack. Average difficulty, I would say, really because there are a lot of systems that do protect from this, but it's a text-based attack. Anytime you put input into the system through data, it's a possibility to launch this type of attack. This attack actually can be stored in a database as well, and so I'll show you an example of how that can happen. Prevalence, very prevalent. This is the most common vulnerability for successfully launched attacks. So you really need to stop the prevalence of this type of attack by closing the loops and not allowing your code to have this type of vulnerability. As far as detectability, it is easy to detect this. Testing and code analysis, static analysis tools can pick up on where this is a possibility. So I highly encourage you to use static analysis tools to identify where these are in your code. As far as impact, moderate impact, scripts can do many things, and so you can use these scripts to hijack sessions, deface sites, insert hostile content, a number of things. You can use it to drop tables, a number of really dangerous things. Here's an example of what a SQL injection attack looks like. So here's under the covers. What you see in the code is you're asking the user to provide their name, and so you're getting that parameter from the screen. And just say that the way you do this is through the URL. Not that you would typically do this, but it's a way to show you what's going on under the covers. And so just say the user's name is Stefan. And what the code wants to do is parrot back and say, welcome, Stefan, so acknowledge Stefan's name. And so if you look on the right there, that's really the HTML code that is laying out this simple welcome Stefan code. But if you did not prevent these cross-site scripting types of attack, instead of Stefan's name, he could have put a script. So in this case, it's just a script that pops up an alert button that says attacked. And you can see what happens on the bottom where this attacked pop-up comes up. Now, which is harmless, this pop-up button is harmless, but just say you can do any other thing. So if you have a script to drop a table, to grab a session ID, all of these things can be enabled just because you didn't prevent this type of attack. That's one type of attack that's called a reflected cross-site scripting attack. This is a stored cross-site scripting attack. And if you look here in one of the input fields, in the address field, actually there is a script put in rather than an address. And so what would happen if you didn't protect from this is into the database in the address field, this script would lie. And then the next time you pulled up this person's address, that's when the attack would occur. So this is how you're storing the attack and then pulling it back out of the database. And here's again some under the covers types of things. This is in HTML. Under the covers, you can see it's asking for a parameter, but the attacker can put in this case, in that parameter, a script that would actually send a cookie with your session ID to their web page. So what you really need to do is to prevent people from putting scripts into their data. So you have to protect, sanitize the data, make sure that you're protecting from, the type of angle brackets and punctuation that would signal that this is actually an attack that's taking place. So preventing input filtering. You look at all of the characters that are in there in the script tags and whatnot and prevent the user from actually being able to put those in. And watching for encoding as well. There's two ways to do input filtering. One is blacklist, one is whitelist. A blacklist says, all the different punctuations, semicolons, and whatever would, in the language you're using, would signal it's a script to prevent the user from using those characters. And so then as soon as the application hit one of those characters, it would say invalid input. That's one way, blacklist. What's actually more commonly used is a whitelist. So a whitelist says, this is good. We allow letters. We allow numbers. And so you are saying, really establishing a grammar for what you would allow the user to input. So that's really a much better way of doing input filtering. But really what you want to do is anytime the user inputs data, you need to make sure it's not a script, or they can execute the script. And so there are libraries that do sanitation. I've provided some names of them here. And OWASP has a cross-site scripting prevention sheet I would highly suggest that you look at as well. Here's another comic, and I will say this comic, it's the XKCD comic, and it is very similar to the drop table one that we had with SQL injection, because these two vulnerabilities are really very related. And so here's a case where they're naming the comic a script, and when they do that, there's bad results that happen. The script is executed, and so the reminder here is to sanitize your database inputs.